This lesson is on factoring by grouping. This is an important lesson because we're going to be using it with other methods of factoring, especially a method called the AC method, which is our hardest method. And if you understand how to factor by grouping originally, it takes away half of the pain and ordeal of learning the next lesson. The thing I want you to understand right now is factoring by grouping is used when you have 4 terms. If you are given a polynomial that has 4 terms, the way to factor it is most likely by factoring by grouping. Of course, you always want to look for the GCF first. We say that for every type of factoring possible. Look for the GCF. But if it has 4 terms, you're most likely going to be using factoring by grouping. So I'm going to start you with this example. X cubed plus 9x squared plus 4xy plus 36y. Notice there's 1, 2, 3, 4 terms. It is a polynomial with 4 terms, so we're going to use factoring by grouping to factor this polynomial. I've already written the steps, so I'd like you to write them down. Make sure you understand them, but we'll go through it with using this example. So step 1, you're going to create binomials with parentheses. Remember, binomials, that makes 2 terms. So I'm going to put my first 2 terms in parentheses, the x cubed plus 9x squared. I'm going to put addition sign in between them, and I'm going to put my second 2 terms in parentheses, 4xy plus 36y. So we've taken our polynomial that's up here and created into 2 binomials with parentheses. Step 2, I'm going to factor out the GCF. You're going to do this every time. I'm going to look at each binomial and factor out the GCF. Well, in x cubed plus 9x squared, there's no number that's common between both. But there is a variable. There's actually 2. X can go into both of these terms twice. So I'm going to factor out x squared, and I'm left with the remainders. X cubed divided by x squared is x. 9x squared divided by x squared is plus 9. Looking at the second one, I have 4xy plus 36y. First, looking at the numbers, I see that I have a common number with 4. So I know I can take out a 4, and I'm left with xy plus 9y. Looking, I also see there's a variable. Y is between both of them. So I can take out 4y, and 4xy divided by 4y is x, plus 36y divided by 4y is 9. So if you notice, what we have here is x squared times x plus 9 plus 4y times x plus 9. If you have factored by grouping, these should be the same or very, very similar. And I will show you an example of what I mean when they're very, very similar later. But these should really be the same. That is your end goal. So step 3, you're going to factor out the common binomial factor. That's what's inside the parentheses. That's what's the same thing. You're going to factor that out and write the remainder, which is what our GCFs are, as another binomial. So if we do that, we're going to factor out x plus 9, and we're going to see x squared times x plus 9 divided by x plus 9 is x squared, and 4y times x plus 9 divided by x plus 9 is plus 4y. So this is my factored form of that original polynomial we started with, x plus 9 times x squared plus 4y. Let's look at another example. We have x cubed minus 2x squared minus 9x plus 18. So, the step 1, I'm going to write them each as 2 binomials with a plus sign in between. Next, I'm going to factor out the common variable, or the common number. In the first binomial, we see that it's x squared, and x cubed divided by x squared is x, and negative 2x squared divided by x squared is negative 2. For the second one, I'm going to factor out. Now in this example, if you remember what I said before, you always want the first term to be positive. So I would get into the habit of taking that out. But I'm not going to take out the negative on purpose so I can show you what I was talking about on the last slide. Let's say I only took out a GCF of 9. I'm left with negative x plus 2. So remember, I said that these two binomials should be exactly the same. Notice that they're not exactly the same, but they're very close. This is the only situation where they're not exactly the same, but it's still okay. Because even though they're not exactly the same, they're opposites of one another. X and negative x, negative 2 and 2. That is the only way it's still okay if these are not exactly the same. Anything else, then you've done something wrong. But we want x squared times x minus 2. How can we get this second binomial to look like x minus 2? Well, if we take out this negative and put it to the outside, we should get x minus 2. So if we do that, we're actually going to have negative 9 times x minus 2. Now remember, I said before this that we always want this first term to be positive. So we really should have taken out negative 9 originally. But it's okay if you don't. You're just going to have to take it out later. Now we're going to factor out our common binomial, x minus 2, and our remainders are the GCFs, x squared minus 9. Now this is very important. You should look at this and go, am I done? Am I done with this? Is everything factored? And hopefully you're saying to yourself, well, x squared minus 9. I just learned how to do that. I know that's a difference of perfect squares. So factor it further. You always need to factor these as far as you can or else you won't get full credit. So we're left with x minus 2, and then this is x squared minus 9. That's going to be x plus 3 times x minus 3. This final answer here, that is your final answer. That is your fully factored form of x cubed minus 2x squared minus 9x plus 18. All right, looking at one more example, we have 5x cubed plus 3x squared minus 25x minus 15. So I can see right now I'm going to put them into two binomials, 5x cubed plus 3x squared plus negative 25x minus 15. I can see that I have a GCF in both, but the point I want to make is sometimes you might not, and it's okay to switch the order of these two terms if it helps you. See, I notice that there's a 3 and a 15. There's going to be a number there. Now this one, it would be fine either way, but you can switch the order of these two. So I could actually have 5x cubed minus 25x plus 3x squared minus 15. I've changed the order of my inner two things. You can factor these either way. It's fine. But I do want to point out that it is possible and sometimes you may need to. So looking at 5x cubed minus 25x squared, we can take out a 5x and we're left with x squared minus 5. Looking at the second one, I see that I can take out a positive 3 and I'm left with x squared minus 5. I'm going to write out my GCF, x squared minus 5. I'm going to write out the common binomial, and then my remainder is going to be the GCF, 5x plus 3. Looking at this x squared minus 5, I would look to see if I could factor it further, but this is not a perfect square, so I'm done. This is my final answer. All right, looking at these last two, I want you to pause the video and try these on your own. All right, hopefully you should have put the first two terms into a binomial and the second two terms into a binomial. Factor out the GCF, so we have 2a, and I'm left with b plus 7. And I don't have a GCF here, But this is incredibly important. I know that I've said 1 is worthless, but you should always pull out a GCF. You need to pull out a 1 when you're factoring by grouping. And we're left with b plus 7. The reason why is because you need a second term when you're putting these together. So I'm going to have b plus 7 times 2a plus 1. If you had not pulled out a GCF of 1 and you had 2a, that wouldn't be correct. And you can always check by foiling and seeing if you get the same answer. All right, with the second one, we have 5x squared y minus x squared plus 5y minus 1. In this first one, I'm going to pull out a GCF of x squared, and I'm left with 5y minus 1. If you would switch the negative x squared and 5y, you'd have a little bit of a different answer right now, but our final answer should be the same. Plus 1 times 5y minus 1. Factoring that by taking the common binomial, I'm going to have 5y minus 1, and the rest is going to be my GCF, x squared plus 1. Can I factor this any further? No, because it's x squared plus 1, and we need the difference of 2 squares. If you got these 2 answers correct, then congratulations, you understand how to factor by grouping.